In the last 2 to 3 years, we've seen a massive interest in adapting clothes with the excitement that's happening around technology. All of those devices that we love to use every day have inspired fashion designers to ask, well, what can we do to make clothes that exciting? It's gotten people excited about what can happen with fashion. What are the possibilities out there with your clothes?
What you're seeing is the kind of technology from aerospace and from automotive is actually trickling down to sportswear, and then that's even trickling down into fashion. So you're seeing the same technology is able to be used in multiple industries. The first 3D printed dress that I did in my career was actually printed in a nylon material. Normally this is a rigid material, it's a hard material. So in order to make it flexible, we had to print small interlocking structures. So we were looking at things like knitting, things like weaving for the kind of idea behind those structures. It was through using these small interlocking structures that we can make something flexible.
One of the dangers of high-tech fashion is that it begins to lose its soul. If you think that fashion that's made by hand involved someone's time and effort, and they cared about producing this garment, so it has more of a personal touch, and that's what you risk losing when you produce everything out of a computer. It tends to feel like it's almost robotic or uniform.
Where the future of 3D printing is really in making better parts. When we can 3D print on a really much smaller scale, we can actually access the kind of atomic level of materials, and we can make new materials that can do things that materials that we have today can't do. It's going to be kind of something that, as a consumer, we're not necessarily aware of. What you'll be aware of as a consumer is that you can get better things. You can go into a store and order something that fits you specifically.
This kind of technology could be seen as revolutionary, as the sewing machine was.
It started 136 years ago with an idea and the flick of a switch. Now, computer engineers and artists are teaming up, turning the lights on and illuminating our wardrobes.
We design electronic fashion.
But these dresses are more than that.
A motion reactive, technology-oriented dress.
That means different dresses react to different things, from the movement of the body to the Earth's magnetic field.
Our goal for the white dress was to kind of create something that looked like lifting, or created this kind of like aura of light.
And for this dress,
as the person moves, based on their footsteps, based on their body motion, it'll send undulating waves of light up and down the body.
But how do you get this to do this?
We start with a design.
I'm the one who works on all the insides of the dresses. I'm not very concerned with what the outsides look like, except where the lights are and how they perform.
We start building, like rough models, sewing something together real quick. A lot of coding and a lot of testing.
It's a balancing act of using delicate electronics in a high-stress environment in order to create some sort of effect. Then we add the sensors and we say, okay, we want to sense footsteps. Well, let's use an accelerometer so we can sense the movement of the hip, or a temperature sensor or a compass.
Red, green, and blue LED lights are carefully placed throughout their creations.
RGB are the 3 primary colors of light, and so by mixing and matching various levels of those colors, we can make any color we want.
Turning an ordinary outfit into a work of illuminated art.
I feel like it's kind of like the next step, and I feel like we're just in with that trend.
Their next project?
I'm kind of excited about a proximity-based design where you have multiple dresses that respond to their proximity to one another. So if 2 dresses get close together, their colors maybe meld and blend. Or if you get all of them together, they're all very bright. Or if they're all far away from each other, they're very dim.
With a glimpse into the future of fashion, this is Inside Science TV.
In 2007, I was talking about this as a production technology, and everybody thought I was crazy. My name is Francis Bittanti. I'm a designer and founder of Francis Bittanti Studio. 3D printing is an additive process, so you build up material layer by layer, micron by micron, until you have a finished part.
If I want it, I can go home, click online, and print the file at home, and I'll have this myself.
Yes, that's correct.
All for $1.
For $1.
Hard to believe. But after printing it out at CNBC headquarters, suddenly, not so much.
Usually you make a drawing as a designer and you go through all this stuff and you lose something. Like it stays consistent as you look. It's exactly what you draw. It's really surreal. It's like seeing something out of your favorite movie real, right? You're like seeing the dinosaur from Jurassic Park. We've recently partnered with Adobe to produce a collection of shoes that we call Molecule. When you look at the shoes, the really special thing about it is that there's a continuous gradient of color. That's the kind of work we're most excited with, because that's where we're achieving material effects that we couldn't do before. Not only could we not do with 3D printing, but we couldn't do with any other type of manufacturing. One example, this dress that we're working on right now, digital files created by our studio, and then that's printed. Those parts were then shipped back to New York, where they're being finished. All the support materials are being taken off, they're being cleaned, and they're being prepped and ready for assembly. And in this case, that dress is going to be sewn together. It's a really exciting time to be in the industry.
Made-to-measure fast fashion is now a reality for ZOZOTOWN customers around the world.
This ZOZO revolution started in Japan today. Today, it travels to more than 72 countries.
The Japanese fashion retailer has developed this skin-tight suit and accompanying smartphone app.
Your smartphone is ready.
It allows users to upload precise body measurements and ensure a perfect fit for the clothes they order from the company's online offering.
Measurements complete.
ZOZO says it's adding business suits and formal shirts to its own line.
The time where people adapt to clothing is over. This is a new era where clothes adapt to people.
ZOZO has global competition. UK-based 3D Apporte says it offers 3D body scanning and the opportunity to try clothes on virtually. And Sweden's VirtuSize uses technology that lets users compare the fit of garments to those they already own. ZOZO is on track to ship 1 million ZOZO suits to customers by the end of July. They'll have a standard price tag of around $360 after an initial discount period. The company hopes its bespoke service will boost the success of its own brand.
An exciting future is emerging, and it's all to do with one fast-changing technology, 3D printing. First used primarily for prototypes and models, the technology has come a long way since its humble beginnings. And with plunging costs and a growing array of printable materials, 3D printing is slowly but surely changing one aspect of our lives, clothes. Scan it, print it, wear it. The future of fashion looks set to be 3D. At least that's the end goal for recently launched collaboration 3D Fashion. The 18-month project run by Loughborough University in the UK and garment company Yare Group aims to revolutionise how clothes are made. And all in a bid to reduce waste and labour costs. Ultimately, they want to create a 3D printing process that can be commercialised and used to manufacture customised clothing. And head of the project, Dr. Guy Bingham, believes this process could change fashion eternally.
But ultimately, you could actually see this technology ending up on the high street. So you can imagine a retail experience where you could go into a store, you could get 3D body scanned, you could select the design that you wanted, that could be modified in a 3D virtual environment, and then could be printed out in front of you.
But the concept isn't an entirely new one. Over the years, many companies have toyed with the idea of making clothing printable. Dutch 3D printer company Ultimaker, for example, were the creators of the world's first 3D printed dress. Atop of that, they have since put together a collection of patterns to download for free, making the process a lot more attainable to the general public. Teaming up with XYZ Workshop, they have created a full fashion suite, including a 3D printed wallet, a 3D printed watch band, and an entire couture dress. And according to co-founder Ka-Wei Lim, 3D fashion for the masses really isn't that far away.
I reckon within perhaps the next 2-3 years, we could start seeing more mass-produced
3D printed fashion in our stores, or it could be available in the form of like iTunes or something.
Following shortly behind in 3D production, the Kinematics dress was created by design studio Nervous System in 2014. And this 3D printed dress set out to push the boundaries of what was possible in computational fashion. By weaving together thousands of interlocking components, the dress was printed out in one single folded piece. A piece which required no assembly at all. But one woman made it her mission to create a wardrobe full of outfits, and that woman is Danit Peleg. During her fashion design degree at Shenka College in Israel, Danit embarked on a 3D printing journey at home. Although she has since admitted it was definitely not cheap or easy. Danit needed a total of 2,000 hours and a lengthy row of 3D printers in order to complete her mission, but the hard work paid off. Her 5-piece collection has since taken to the runway and received many positive reviews, thus proving a powerful 3D printer, or 5, and an innovative mind can change everything. And while many creators are working towards making the full garments, there's one company dedicated to providing the fabric. Electroloom, the world's first 3D fabric printer, enables people to design and manufacture clothes from scratch. And with over $80,000 raised on their Kickstarter campaign, the team's concept is finally turning into a reality. Eliminating the need for thread, needles, or sewing, the Electroloom Developer Kit means only simple skills are needed to design the patterns, and the kit does the rest.
So this is a 2D sheet that was printed on the machine. So you can see it behaves like fabric. It's much different than a lot of the stuff coming off 3D printers today.
Although still in its infancy, the company hopes to one day reach the mass market. But the industry still remains in an interesting limbo, somewhere between high art and mass-produced, ready-to-wear ensembles. This year's Met Gala focused on the museum's main exhibition, Manus Ex Machina. Meaning hand versus machine, the exhibit focuses entirely on how technology is transforming fashion. A notion creator Andrew Bolton believes should be discussed.
Traditionally, the handmade has been seen as being about luxury, about superiority. It's also been seen as something that's elitist. Whereas the machine, it's been about progress in the future. And on the other side, it's been about mediocrity and dehumanization. I'm finding that those values don't really hold up. Sometimes a garment that's been machine-made actually has more hours spent on it, is more luxurious than doing it by hand.
Here, in the school's brand new Physical Sciences building, professors and grad students develop wearable tech.
What our lab does, along with Professor Deepak Ganesan, is make smart garments. And it's effectively a way of having your clothes tell you how you're moving, how your heart rate is beating, how you're breathing during different parts of your day. And that's simply a way of taking something that you wear every day and using it to give you some kind of health-related information. So I called this a supercapacitor. But
Professors Trisha Andrews and Deepak Ganesan are the two leaders behind this health monitoring technology.
So I think the real potential of this is just natural, regular clothing, being used as a sensor. And I want to distinguish that from, you can take the electronics in a Fitbit and then just stitch it into clothing. That doesn't really make it a textile-based wearable, right? And what's magical about this, I think, is just that the thread itself is sensing.
This is one of the first prototypes that we built.
The team developed an armband that monitors physical activity. It detects your movement and sends it to a computer program. The researchers say this device can tell specific movement, from brushing teeth to sleeping.
We're looking specifically at sleep posture to figure out if there's something wrong with your breathing when you're sleeping, or if you're sleeping in the wrong posture that's leading to health problems. We're looking also at how you're moving your joints, specifically your elbow and your knee and your hip, because if we could somehow map that out, that tells you about how well you're moving, how your body is moving in relation to your absolute normal, and also that could be an indicator of potential illnesses. Without lamination, it holds charge for 3 hours. What we do is actually figure out how we could take electronic textiles and make garments out of it. And we specifically use a device called a triboelectric. And what that does is anytime you squeeze it by, for example, physically bending an elbow or your knee, you create a contact between 2 layers of fabric. And then when you release your elbow, that contact releases. And we use that physical contact to generate an electronic signal. We are a cross-disciplinary team of chemists, chemical engineers, and computer scientists and electrical engineers. And we all work together across our 2 labs at the UMass campus in order to figure out how to make the garment, what kind of device to put on the garment, and then how to process the signal so that we're actually getting meaningful information out of just a really simple electronic impulse. My wonderful engineering students learned how to sew and weave, and they make our garments, yes, and I'm very proud of them.
They employ vapor chemistry to their fabric, which is an eco-friendly way of making the garment both washable and conductive to electricity.
We've been working on this project together for about 2 years, ever since my lab moved to UMass Amherst. We come in every day and we think of a way of, can we put it on a garment and make it useful and durable, and that's what my students do every day, and that's what I think about science grad school, is just having the, the desire to make something new that would help you in your future in your life.
This is exciting for healthcare, and I think it's still a ways away, but I think we're making some very strong progress.
Everybody wants them, but we've got them. This is the Adidas Futurecraft 4D. It's one of the rarest shoes in the world today, but give it a few years, I guarantee it'll be amongst the most popular. It will be the first mass-produced 3D printed shoe. And Adidas has been developing this technology for a long time. It's only recently, though, that teaming up with this company Carbon, that they co-developed both this elastomer and the technologies to print this quickly at scale. The promise is not just this really cool aesthetic, it's also that they will soon be able to mass customize shoes. So basically, if you walk differently than someone else, they could make a shoe to match. You know, Nike, Under Armour, New Balance have all shown off their own 3D printed concepts. But Adidas is really the first that's proven that they will be able to do it at scale, and that's why it's so exciting. They're looking at building shoes in completely new ways. You know, as their creative director has explained to me, there's no limits on what they can design as soon as they can build a shoe part by part. You know, ultimately it's gonna drive creativity, it's gonna drive performance. And you know, honestly, I don't think it's a gimmick. I think this is legit technology that will strongly influence shoe production and design for the next 5 to 10 years. So they'll make a few thousand of these shoes this year. Next year, they promise to make 100,000, and after that, they won't really say, but you could imagine it scaling into millions. You know, but none of that would matter if the shoe didn't feel great on your foot, and it really does. It's really different than anything I've ever worn. You feel the airflow from this mesh under your sole, almost like you're wearing a flip-flop. It has way more spring than you would think, and it doesn't just collapse when you step into it, which is how it might look. You know, shoes have been made for the same way for decades now. You take a mold, you squirt some EVA foam in it, then you weave an upper and it's made. Futurecraft 4D promises to change the way shoes are made entirely, which will impact how they can be designed, how they can be sold, how they can be purchased. It's really more than just a new midsole. It's potentially the future of shoe design.
Oh my God, am I gonna break this shoe? Go in there. Oh, it steals me. Nike's introducing its second version of its self-lacing, hyper-adapt shoes, the Adapt BB. And this pair is a lot more affordable at $350, pairs over Bluetooth, and remembers how tight you like your shoes. It's a ton of technology packed right under the arch of your foot. People are probably going to buy it in droves just like they do with most any other Nike shoe. But what does it mean when your shoe acts more like a gadget? We wanted to see what they're all about, so we're here today at Nike's campus to try them out. Okay, so these are them. This is a prototype version. This is not the colorway they're going to be released in, but I've never worn these before. I've never worn the first version either. After all of this hype, this is kind of hard. Okay, that's in. Let's see if I can press some buttons. Oh, now we're tightening. Ooh, it's gonna give you my foot a hug. Yeah, that is much tighter. Can you guys picture LeBron doing this at the sidelines during a game? Pressing down on his buttons. Although these were neat to try on and unlike any other shoe I've ever worn, I'm not convinced the self-lacing shoes are the future. So I chatted with Nike visionary, longtime designer of the Jordans, and the creator behind the self-lacing shoe concept, Tinker Hatfield.
I was invited into the process of designing products for Back to the Future 2. It just occurred to me, a shoe that could come alive when you touch it, and it recognizes you, essentially adapts to you. Seemed like a very out there futuristic idea, but on the other hand, it also seemed like it would be doable at some point in time.
Power laces, all right.
The Back to the Future shoe was just a prop. There were people controlling the shoe through strings below the floor. Actual self-lacing shoes didn't come out until the Nike Mags in 2016. Then a few months later, the HyperAdapt 1.0s followed. This third version refines everything from those two shoes and gets the HyperAdapt ready for a wide release.
Such a huge amount of effort and engineering that went into this motor, and it's not just the invention of the motor, but then it's how it's been finalized so we can build it for many other people to use.
This motor is key to making the shoe mainstream. The HyperAdapt 1.0 had tons of cables and wires connecting the laces, motors, and lights. It was a tangled, delicate setup. Compare that to the Adapt BB, where the shoe's technology has been completely re-engineered for mass manufacturing. All the shoe needs to make it smart is its lacing cable and lace engine. The cable is threaded through the motorized spool you see in the lace engine, which then winds around the spool, making the shoe tighter. All the techie stuff is in that engine too, literally everything. Of course, you don't think about any of the tech inside when you're wearing the shoes, but that doesn't change the fact that you're walking on top of a lithium-ion battery and a bunch of other electronics. That's a little scary to me. Jordan Rice, engineer of HyperAdapt, tells me not to worry though, and he walked me through how the team tests the shoes to make sure they won't explode.
So we put it out in the field, we put it on athletes, we've put it on NCAA athletes, semi-pro athletes, athletes that play professionally overseas and come home for the summer, and then regular athletes playing hoops on a Thursday night. We literally beat it up really, really hard right over top of the lace engine in the shoe.
All right, so like vintage HyperAdapt 2.0.
So you mean like 5 years down the line?
Yeah, like 5 years, I wore the hell out of mine, but I'm ready to sell them. Because if the battery's dead, I can't, it doesn't matter about the app support or anything, it's just like I can't tighten the shoes ever again, right?
Yeah, I mean, the shoe is dependent on this lace engine. There's not a manual lacing method for it. In terms of battery decay, most of the batteries that you see decay in your normal devices do so because they're being charged and discharged every day. And so you have a certain number of cycles. You go through 365 of those on your phone in a year. It would take you a very long time at 10 to 14 days battery life to go through 365 on these.
Jordan thinks this shoe isn't going to die anytime soon. And anyway, the shoe is smart enough that it will always save enough battery to unlace. Worst case scenario though, you can check your battery life through the app and control some other things.
Pair it over Bluetooth, and then it'll do a quick tighten, loosen on your feet to sense kind of the optimal setting. Once you have a setting you like, you can also set a mode and save it.
Self-lacing shoes are a really interesting idea that anyone who geeks out on tech or sneakers will probably want to try. Personally, I'm not going to rush out to buy these shoes because I'm not a sneakerhead and I'm not a basketball player. These just aren't the right shoes for me right now. But Nike really seems to believe these are the future.
We've learned how to make shoes a lot better so they don't stretch as much. But everybody wants fresh, new shoes all the time. Our next goal will be to make this in more colors and more styles. If somebody switched shoes, we would like them to, and they would probably like to switch to another shoe that has the same technology in it.
Nike clearly has grander plans for this technology, and you can even see hints of it in the name. Adapt BB stands for Adapt Basketball, so in the future, a different kind of shoe might have a different name, like a running shoe might be Adapt R or something like that. But even if this adaptive fit technology doesn't take off, it's not the end of the world. Nike will go on, and so will laces.
And we'll make sure that they're still cool shoes even 20 years from now that have laces. We shake on that?
We'll hold you to it. I was always very curious about the world around me. I was one of those kids that sits at the front of the classroom, raises their hands, and asks all the questions. I think when you hear engineering when you're young, it can be quite scary. It sounds very, very technical. But engineering is great because that is many, many different types of fields. You can do something you never expected to do. There is something for everyone. You can start from something very, very technical and end up doing fashion shows. I decided to become a lighting designer because it gave me the opportunity to combine my two passions, science and art. I'm very passionate about the fashion industry because it gives you an opportunity to express yourself in different ways. And I use fashion in order to show my confidence in a way. The fashion designer has a certain idea, but we as engineers make it real. What I most love about my job is the variety. Every project is different, every day is different, and this is what makes it very exciting for me. My biggest achievement today is when I've replicated daylight using electric lighting in real time. I really love that. It has never happened before, and it's really exciting that it works well. I think when I was 16, I had this idea of engineering being something very, very manly in a way, but it's not really. And I think it's important for young people to understand that it's not just pipes and air conditioning units. There is a lot more you can do.